difficult. They'll take 2 hours a lesson. I saved the best till last. So I know it doesn't look like there's much left, but these are 2-hour lessons because they are huge.
76, 78?
Yeah.
No, the next 76? Yeah, big.
Well,
Yeah. And also, I want to give some time to the maths coursework. Then once it's finished, we'll do exam papers. Okay, let's have a look at the next topic now. Can you get the light, please? I know I have to make you move, it's so terrible. Right. What's wrong now? What? Okay. In semester 1, you learned how to calculate area. For example, if you have something like this, A, B, Fx, and you want this area, the area is the integration from A to B, Fx dx. That's the area. In fact, you can use integration to calculate volume as well. Volume, area is 2 dimensions. Volume is 3 dimensions. If you didn't know that word. What's wrong with you? Right. Anyway, how to calculate volume. So, this is for today. Imagine, for example, you have a curve like this, and you rotate it around the x-axis. What shape would you make? You'd make a cone, yeah? It's a cone. Indeed. Right, let's do something else. What about if you had a shape like this, a horizontal line, and you rotate it around the x-axis? What shape would this make? Yeah, make a cylinder when you rotate it around. Let's do one more example of how this works. If you had a semicircle and you rotate it around, what shape would you make? A sphere, a ball shape. Okay, and this is A and this is B. But what's nice about this formula I'm going to show you, it can work for any shape. So if you had a shape like this and you rotate it around the axis, what shape will that make? Who knows? Some strange shape, okay? But my point is, we have a way to calculate the volume. I call this A, and I call this B. If you want to calculate the volume, it's like area, except for 2 differences. You multiply your answer by pi, and you don't integrate fx, instead you integrate fx squared. Yeah. This is how you can calculate volume. Let's do an example.
Excuse me?
Yeah.
Why you multiply by just 1 by? The circle is 2 by.
Yeah, now the proof, I was going to do it, and I can still do it. But the reason for the pi comes from the proof, and what's actually happening here is there's lots of circles here which are being combined together to make the volume. So the pi is really on the inside with the f. But this is something I don't want to get into because you don't need the proof for the exam. It's a little bit complicated. Okay, do you have this formula? Yeah? let's do an example. I want to do an example where we know the answer already, so we can see that it works. Yeah. Okay, so let's take this one as an example. Let's say this here is 0 and this here is 10, and the function is fx equals to 2, and this here is 2. So it's just a flat line. If I rotate this, what shape do I make? I make a cylinder. What's the height of the cylinder? 10. And the radius of the cylinder? 2. Yeah, be careful because it's 2 and 2. Yeah. So what would be the volume here? It's pi r squared h. So it would be 400 pi. So let's use our new formula from today and see if we get 400 pi. Okay, so the formula says the volume will equal pi integrate 0 to 10 2 squared dx. That will equal pi 0 to 10 4 dx. What do I get when I integrate 4? 4x 0 to 10. Oh, sorry, it wasn't 400 pi, it was 40 pi. If I put in that, I get 40 pi, which is right. I accidentally said 400. It was my mistake, I didn't mean 400 pi, it's 40 pi. So 40 pi is the volume. Let's do another example. Let's do a cone. Can I scroll down? So I have a shape like this. Y equals x, and we'll say this is 1 and this is 1. So I know that this shape will make a cone. And I think its volume will be pi over 3 when we do it. Let's see what we get. The volume will be pi integrate from 0 to 1 x squared dx. This will equal pi x cubed over 3 0 to 1, which will equal pi over 3. What's wrong? Here I put in the 1 and the 0, yeah? 1 over 3 minus 0 over 3. Pi over 3. No? Part. The whole thing. Let's do another example. Can I scroll down? Right, so let's say you have a quadratic y equals x squared, and you rotate it and you make some weird shape, whatever it is, some shape. The volume is pi a to b f of x squared dx. That's pi, let's say 0 to 1. 0 to 1, what goes here? X squared squared dx. That will be pi 0 to 1 x 4 dx. What do you get when you integrate here? X 5 over 5, 0 and 1. That will equal pi 1 over 5 minus 0 over 5. So the answer is pi over 5 is the volume. So I'm using this formula. This is the calculate volume. What's wrong?
Where did you get x over 5 over 5?
Oh, you break my heart. Increase the power by 1 and divide by the new power. It's integrate in x4. Okay, did you write this down? Yeah. So I want you to try this one. Let me squeeze it in here. And I don't want to make it too difficult. Let's say you have this shape, root x. No, too small? Okay. Do I need to wait for you to write this down, or can I move down? Can I move down? Okay. Right, try this one. So here is root x, and let's say this is 0 and this is 4, and you rotate it. And I want to know the volume. In fact, I know what this shape is. I don't know if anyone else knows it. If you rotate root x, does anyone know what shape it makes? I'll tell you what it makes. I'll draw it for you. No, it doesn't make a house. But on the top of your house you have a satellite dish. And this bowl shape is the exact same shape you get when you rotate root x. So it actually is it makes a kind of dish shape. Okay, calculate the volume here. Oh, I can't quite see it there. There you go. You got this, Leon? Yeah. Okay, let's have a look. So, volume will equal pi 0 to 4 root x squared dx, pi 0 to 4 x dx, pi x squared over 2, 0 to 4. 4 squared is 16, divided by 2 is 8, so it'll be 8 pi. No need to put in the 0 because it's just 0. Okay, so write this down if you didn't get it or if you did get it. And I'll give you another one to try. More difficult now. Can I scroll down? Yes, Marcelo? Yep. Okay. Try this for me. Hey, no bad words, please. I know this word. Be good. Or I'll kick you out. Right. Okay, so here, this curve is y equals square root 1 minus x squared. Sorry, hang on. There we go. So you rotate this, and what shape do you make? Make a sphere. So I want the volume here. I don't tell you the limits, you need to work them out. It's from here to here. You know how to get the limits?
No.
These points are called the roots. How do you find the roots?
Equal 0.
Y equals 0. What equals 0? Y equals 0.
1 and minus
Yes. Okay. No, not quite yet. Okay, let's have a look at this one now. So firstly we need to find the roots. Y equals 0. That means root 1 minus x squared equals 0, which means 1 minus x squared equals 0, which means 1 equals x squared, so x equals plus or minus root, like somebody said at the start. So that's minus 1 and that's 1. The volume will be pi integrate from minus 1 to 1 root 1 minus x squared dx. So that is pi integrate minus 1 to 1 1 minus x squared dx, yeah. Pi minus 1 to 1, pi minus 1 to 1. Okay, so when I integrate 1, what do I get? X. And when I integrate x squared? Cubed over 3. So this will be pi. First we'll put in 1. Then we'll put in minus 1. If I put in 1, I'll get 1 minus 1 over 3. And when I put in minus 1, I get minus 1 minus minus 1 over 3. So carefully add these together now. Pi 2 over 3 minus, now minus and minus makes a plus, so that would be minus 2 over 3. So that would be 4 over 3 pi. Now this shouldn't surprise you, because, I don't know if you remember this from middle school, but when you have a sphere with radius r, what's the volume? It's 4 over 3 pi r cubed. And if the r is 1, 4 over 3 pi. So you get the same answer. Okay, there you go, write that down. if you didn't get it. Yeah. Sometimes in the exam they put in, instead of 1, they might put in like or squared. It's nearly the same type of question. What would be the difference at the start if it was an or squared? The roots would be
Or and minus.
yeah, or and minus or. And instead of 1 here, it'd be or and minus or. So you'd get 4/3, and then I think there'll end up being a pi or cubed in the answer. Anyways, that's more difficult maybe than what's common in the exam. Okay, you have this written down? So can you try some of these for a few minutes? This question on the exam is not very common on the exam. You don't get it too often. Okay, try these for a few minutes. Can I close this? Yes?